interstellar travel could be possible even without spaceships, scientists say. Well, that's a new one. No spaceships? No problem. Okay, how are they going to do it? In about 5 billion years, the sun will leave the main sequence and become a red giant. It'll expand and transform into a glowing, malevolent ball and consume and destroy Mercury, Venus, Earth, and probably even Mars. In other words, everything in the inner solar system before the asteroid belt and Jupiter. Can humanity survive the sun's red giant phase? Extraterrestrial civilizations, ETCs, may have already faced this existential threat. Could they have survived it by migrating to another star system without the use of spaceships? Universe Today renders a well-versed in the difficulties of interstellar travel. Our nearest neighboring solar system is the Alpha Centauri system. If humanity had to flee an extraterrestrial threat in our solar system, and if we could identify planetary home in Alpha Centauri, it would still take us over 4 years to get there if we could travel at the speed of light. It still takes us 5 years to get an orbiter to Jupiter at our technological stage as it is today. There's lots of talk about generation starships where humans could live for generations while en route to a distant habitable planet, assuming nothing impacts them and they get there safely. Now, those ships don't need, that's my cynical comment, those ships don't need to reach anywhere near the speed of light. Instead, entire generations of humans would live and die on a journey to another star that takes hundreds or thousands of years. It's fun to think about, but pure fantasy at this point. Is there another way, or other civilizations could escape our doomed homes? The author of a new research article in the International Journal of Astrobiology says the ETCs may not need starships to escape existential threats and travel to another star system. They could instead use free-floating planets, also known as rogue planets. The article is, quote, Migrating Extraterrestrial Civilizations and Interstellar Colonization, Implications for SETI and SETA. The author is Irina Romanovskaya. Romanovskaya is a professor of physics and astronomy at Houston Community College. She says, I propose that extraterrestrial civilization may use free-floating planets as interstellar transportation to reach, explore, and colonize planetary systems, is what she says. And when it comes to the search for other civilizations, these efforts could leave technosignatures and artifacts. Well, okay, let's say you get to a free-floating rogue planet. The thing is, it goes all over the place, and its temperature is always changing, let alone its atmosphere, whatever else, its seismology. Anyway, she says, I propose possible technosignatures and artifacts that may be produced by extraterrestrial civilizations using free-floating planets for interstellar migration and interstellar colonization, as well as strategies for the search for their technosignatures and artifacts. It's possible that rogue planets, either in our Milky Way galaxy or some of the other hundreds of billions of galaxies, carry their own life with them in subsurface oceans kept warm by radiogenic decay. Then if they meet a star and become gravitationally bound, that life has effectively used a rogue planet to transport itself, hopefully, to somewhere more hospitable. So why couldn't a civilization mimic that? We think of free-floating planets as dark, cold, and inhospitable, and they are unless they have warm subsurface oceans, but they also offer some advantages. Free-floating planets can provide constant surface gravity, large amounts of space and resource, Romanovskaya says. Free-floating planets with surface and subsurface oceans can provide water as a consumable resource and for protection from space radiation. An advanced civilization could also engineer the planet for an even greater advantage by steering it and developing energy sources. Romanovskaya suggests that if we're on the verge of using controlled fusion, then advanced civilizations might already be using it, which could change a frigid rogue planet into something that could support life. The author outlines 4 scenarios where ETCs could take advantage of rogue planets. The first scenario involves a rogue planet that happens to pass by the home world of an ETC. How often that might occur is tied to the number of rogue planets in general. So far, we don't know how many there are, but there are certainly some. In 2021, a team of researchers announced the discovery of between 70 and 170 rogue planets, each the size of Jupiter, in one region of the Milky Way galaxy. And in 2020, one study suggested there could be as many as 50 billion of them in our galaxy. Where do they all come from? Most are likely ejected from the solar system due to gravitational events, but some may form via accretion as stars do. Another source of rogue planets is our solar system's Oort cloud. If other systems also have a cloud of objects like this, they can be an abundant source of rogue planets ejected by stellar activity. Ramanaskaya writes, stars with 1 to 7 times solar mass undergoing the post-main sequence evolution, as well as supernova from a 7 to 20 times solar mass progenitor, can eject Oort cloud objects from their system so that each object becomes unbound from their host stars. But how often can an ETC, or our civilization, expect a rogue planet to come close enough to hitchhike on? A 2015 study showed that the binary star W0720, Schultz's star, passed through our solar system Oort cloud about 70,000 years ago. While that was a star and not a planet, it showed that objects pass relatively close. If the study that predict billions of free-floating planets are current, then some of them likely pass close by or right through the Oort cloud long before we had the means to detect them. The Oort cloud is a long way away, but a sufficiently advanced civilization could have the capability to see a rogue planet approaching and go out and meet it and hitchhike it. Now, the second scenario involves using technology to steer a rogue planet closer to a civilization's home. With sufficient technology, they could choose an object from their own Oort cloud, assuming they have one, and use a propulsion system to direct it towards a safe orbit near their planet. With sufficient lead time, they could adapt the object to their needs, for example, by building underground shelters and other infrastructure. Maybe with adequate technology, they could alter or create an atmosphere. The third scenario is similar to the second one. It also involves an object from the civilization's outer solar system. Ramanaskaya uses the dwarf planet Sedna in our solar system as an example. Sedna has a highly eccentric orbit that takes it from 76 AUs from the Sun to 937 AUs in about 11,000 years. With sufficient technology and lead time, an object like Sedna could be turned into an escape ship. The author notes that civilizations capable of doing so would be advanced civilizations that already have their planetary systems explored to the distances of at least 60 AU from their host stars. 1 AU is the distance between the Earth and the Sun, which is about 93 million miles. There are lots of potential problems. Bringing a dwarf planet from the distant reaches of the solar system into our inner solar system could disrupt the orbits of other planets, leading to all sorts of catastrophes and hazards. It's like playing a game of billiards. But the dangers are mitigated if a civilization around a post-main sequence star has already migrated outwards with a changing habitable zone. Ramanaskaya discusses the energy needed and the time required in more detail in her article. The fourth scenario also involves objects like Sedna. When a star leaves the main sequence and expands, there's a critical distance between objects will be ejected from the system rather than remain gravitationally bound to the dying star. If an ETC could accurately determine when these objects would be ejected as rogue planets, they could prepare it beforehand and write it out of the dying solar system. That could be extraordinarily perilous, as periods of violent mass loss from the star creates an enormous hazard. In all of these scenarios, a rogue planet or other body is not a permanent home, it's a lifeboat. For all of the above scenarios, free-floating planets may not serve as a permanent means of escape from existential threats, the author says, because of the waning heat production in their interiors. Such planets eventually fail to sustain oceans of liquid water, if such ocean exists. Free-floating planets are also isolated and have fewer resources than planets in the solar system. There are no asteroids to mine, for example, and no free solar energy. There are no seasons and no night and day. There's no plants, animal, or even bacteria. There's simply a means to an end. Therefore, instead of making free-floating planets their permanent homes, extraterrestrial civilizations would use the free-floating planets as interstellar transportation to reach and colonize other planetary systems, writes Romanovskaya. And in her article, Professor Romanovskaya speculates where this could lead. She envisions a civilization that does this more than once, not to escape a dying star, but to spread throughout a galaxy and colonize it. She says, in this way, a parent civilization may create unique and autonomous daughter civilizations inhabiting different planets, moons, or regions of space. A civilization of cosmic hitchhikers would act as a parent civilization, spreading the seeds of daughter civilizations in the form of its colonies in planetary systems. She writes, this applies to both biological and post-biological species. Humanity is only in the early stages of protecting ourselves from catastrophic asteroid impacts, and we can't yet manage our planet's climate with any degree of stability, so thinking about using rogue planets to keep humanity alive seems pretty far-fetched. But Romanovskaya's research is not about us, it's about detecting other civilizations. All of this activity could create technosignatures and artifacts that signified the presence of an ETC. The research article outlines what might be and how we could detect them. Rogue planets used as lifeboats could create technosignatures like electromagnetic emissions or other phenomena. An ETC could use solar sails to control a rogue planet or use them on a spaceship launched from a rogue planet once they have reached their destination. In either case, solar sails produce a technosignature cyclotron radiation. Maneuvering either a spacecraft or rogue planet with solar sails would produce cyclotron radiation caused by the interaction of the interstellar medium with the magnetic sail. Infrared emissions could be another technosignature emitted as waste heat by an ETC on a rogue planet. An excess amount of infrared or unnatural changes in the amount of infrared could be detected as a technosignature. Infrared could be emitted unevenly across a planet's surface, indicating underlying engineering or technology. An unusual mix of different wavelengths of electromagnetic energy could also be a technosignature. The atmosphere itself, if one existed, could also hold technosignatures depending on what was observed. It could contain evidence of terraforming. For now, astronomers don't know how many rogue planets there are or if they're concentrated in some areas of the galaxy. We are at the starting line when it comes to figuring these things out, but soon we may get a better idea. The Vera Rubin Observatory should see the first light by 2023, that's next year. This powerful observatory will image the entire available sky every few nights, and it'll do it in fine detail. It houses the largest digital camera ever made, a 3.2 gigabyte CCD. The Vera Rubin will be especially good at detecting transients, that is, anything that changes position or brightness in a couple of days. It'll have a good chance of spotting any interlopers like rogue planets that might approach our solar system. There's a strong possibility that some of those rogue planets will exhibit unusual emissions or puzzling phenomena, and scientists will probably puzzle over them as they did over Huma, the interstellar comet. Maybe another civilization more advanced than us has already faced an existential threat from their dying star. Maybe they made a Herculean effort to capture a rogue planet and engineer it to suit their needs. Maybe they've already boarded it and launched it towards a distant, stable, long-lived yellow star with rocky planets in its habitable zone. Maybe they're wondering if there is any life at their destination and how they might be received after their long journey. This was originally published on Universe Today, and it's on Collective Spark. This is by Alan Boyle. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support. and that you find all my content so interesting. You'll find the Patreon account details in the description box below.